Hello everyone, we are group G1T4 and today we are presenting our auto-grading system project. Our program supports the simultaneous marking of multiple assessments. As an examiner, you can upload up to 5 assessments at once. For each assessment, you simply provide a name and upload the required materials: the student's submission zip file, the code question paper zip file, a score sheet containing student names and emails, and the question paper in PDF format. Please note that submitting a tester zip file is optional, as our program utilizes AI to generate functional tester files for grading. After clicking Upload All Assessments, our LLM scans the question paper to determine the mark allocation for each sub-question and calculate the total marks per assessment. We recognize that AI-generated responses are not always 100% accurate, and therefore, we have included an option for examiners to manually modify or add marks. For exams 1 and 2, since I haven't uploaded any manual tester files, I will generate test cases using the AI. For exam 3, I've already prepared a tester zip file, so I can skip the generation phase and move directly to grading. Once the tester files for exam 1 are generated, the examiner can view and edit them if any discrepancies are found in the AI logic. For example, I will now edit the tester file for question 2A and save the changes before proceeding. As you can see, our program supports multiple ongoing assessments running at different phases simultaneously. For exam 2, which includes the class path question, our AI has successfully generated a tester to mark the submission, as shown in question 4 tester. While the program runs its grading pipeline, I will introduce our grading and penalty rules. We have identified 7 distinct violation types, ranging from hard-coding answers and compilation failures to structural issues with submissions, such as missing, extra, or incorrectly named components. We also account for more technical errors, such as creating infinite loop or using incorrect package names. Our program is designed to automatically identify these violations and document them clearly under the remarks section of our generated reports. To maintain grading integrity, we have established 4 primary penalty rules. The first category covers the failure to rename the zip submission, followed by incorrect file hierarchies, missing student information in file headers, and improper package naming conventions. Now that exam 1 has finished grading, let's review the results. Below, you can see the execution log summarizing the process. The program generates 2 primary reports: a score sheet which includes statistical analysis and a plagiarism report. Each report is named according to the assessment name you set earlier, making it easy to differentiate between multiple graded exams. When I open the updated score sheet for exam 1, the first tab displays the individual grading results per student. This includes everything from raw marks and grading remarks to final adjusted marks, penalty details, and plagiarism flags. You'll notice the results for exam 1 match the ground truth provided by Prof. These statistics are calculated using raw scores before penalties to provide a clear overview of cohort performance. I will discuss the penalty logic in detail shortly. Next is the dashboard tab, which provides a statistical summary of exam 1, including the average, standard deviation, and pass-fail rates. The grade distribution tab visualizes the number and percentage of students in each grade bracket. We also have question analysis, which breaks down performance by sub-question. The student ranking tab sorts the cohort from highest to lowest score. Finally, the performance matrix displays a grid of marks per sub-question per student. Like the main score sheet, this is color-coded to help examiners quickly assess how the cohort performed on specific parts of the paper. This analysis is invaluable for internal references and future curriculum planning. The next report is the plagiarism report. The first tab shows all students flagged for plagiarism, and the second tab covers all students with matching fingerprint with another student. So as you can see here, we have a similarity percentage and a number representing shared fingerprints. In this rightmost column, you can see each pair along with the percentage similarity. In the shared fingerprint field, You can see that this number represents the shared fingerprints, while the two numbers at the back show the number of total fingerprints in each student's work. I will now download the reports for exam 2. This demonstrates the system's ability to successfully grade class path questions as seen in question 4. Finally, let's look at exam 3, which highlights how our program adapts to specific grading and penalty rules. We'll examine the edge cases. For edge cases 1, 3, and 4, these had missing folders or files. The system detected these omissions and flagged them in the remarks. No marks are awarded for missing components. Edge case 2, this submission contained an extra folder. The system simply ignored it and proceeded with the required files. Edge cases 6 and 7, the folder or file are misnamed. System will flag it out and not mark the component. Edge case 8, this is a critical case where the student failed to rename the folder the internal file headers. Consequently, the program could not identify the owner. You'll see that Sean's year 2024 shows no score and is marked as a missing submission. The system redirects the examiner to the Anomaly tab to identify the owner. While we can assume the unnamed file belongs to Sean in this instance, we encourage examiners to check manually to ensure integrity. Edge case 9, here, the student renamed the zip file but forgot to update the internal headers. He received a missing header penalty, which is reflected in his final score. Edge case 10, similarly, this student updated the headers but not the zip file name, resulting in a penalty. Edge case 5, this shows a nested folder structure. The system still grades the content but flags it for improper hierarchy and applies a penalty. Edge case 11, for the infernal loop in question 1a, the system terminated the process and flagged it as a timeout. Edge case 12, lastly, for a wrong package name, the system still marks the question but flags the error and deducts marks accordingly. And this concludes our demonstration of how the system maintains rigorous grading standards while handling diverse submission errors. Thank you.